Hi folks, Mr. Long here for the third of 3 screencasts on solving 3x3 systems of equations, which means 3 equations and 3 unknowns. So we've done number 1 and 2 in the first screencast. Now we're going to work on number 3. Number 3, we're not going to have the 2x2 system contained within a 3x3 system anymore. So let's take a look at what we need to do process-wise. So the first part of it is looking really at the initial setup of the matrix. So again, number 1 here says, process-wise, step 1 is if two of the equations contain only 2 variables and they are the same variables, solve a 2x2 system. That's what number 1 and number 2 are like. So if there's a 0 in only one equation, place it in row 3. That makes it easier to eliminate one of the other variables. If an equation has no zeros but has a 1 in front of it, like a coefficient of 1 in front of x, y, or z, and it can be -1, we always place that in row 1 because we like to have 1s in row 1 because think of it, if you've got a 1 for x in row 1 and a 2 for x in row 2, you just have to multiply row 1 by 2 and then subtract. Okay, so 1s and -1s are really nice to have in row 1. Okay, so that's the setup, and that can occur, before or after you common factor. So let's go over and take a look at what we're going to do here. So look at these 3 equations: 3x, 4y, -4z, 1x, -7y, -2. So one of our rules was if we had a 0, 1, 0, that always went in the third row. Okay, so I need to put that in the third row. 1, -7, 0, -2. And always make sure you did that right. Make sure there were 0 z's. And in fact, there were 0 z's. Okay, it won't always look like that. Sometimes the 1x and -7y will be written right there, which you might think of it as y and z instead of x and y. So then we need to look and say, is there going to be a 1 somewhere in a row that doesn't have a 0 in it? Okay, is there going to be a 1 somewhere where there's not a 0 in it? So I've got a 2, a 6, a -8. Would there be a common factor there in 24? Yes, there would. What is that common factor? Well, 2 definitely, because they're all even numbers. That means if I took a 2 out of all of those, I'd end up with a 1 there. So I would have a 1. And it doesn't matter if the 1 is in front of x, in front of y, or in front of z. But it looks like I'd like to put that one in the first row. So that's going to be 2, 6, -8, and 24. Now, if you were doing this by hand, you would divide all those by 2 right away. And then the second row is going to be the one that's left over. 3x, 4y, -4z. 3x, 4y, -4z, and 23. And it's always good to do a double check. 2, 6, -8, 24. Yep. 3, 4, -4, 23. Yep. 1, -7, 0, -2. That works. Again, is there any common factoring? Yes, there is. There's no common factoring in row 3. I should put a 1 there. But there is common factoring in row 1. So I can take a 2 out of all of those. Whoops, put a 2. Oh. Just 1 second, folks. Sorry, folks, my internet was down, so the editing wasn't working. Okay, so let's take that 2 out. Maybe not a 12. Let's take out a factor of 2. Okay, so now we have a 1 here. And, looks like, no O's are needed. I was thinking that these were all the same, but they're not. And that should be a 1 there as well. Okay, so what's my next step? I need to start eliminating. It's very clear that I'm going to be eliminating. I've got 0z here, so I want to have 0z in row 2 as well. Okay, because I want to get a 2x2 matrix. Remember that. 2x2 matrix. So I've already got a bit of a head start because there's no z's here. So I need to make no z's in row 2. So I'm going to use row 1 and row 2 to eliminate a variable. That variable will be z. Okay, so how am I going to get the z coefficients the same? Or are they already the same? I've got -4 here and -4 here. Well, again, if I multiply by -1, either one by -1, I can add the equations. Okay, and I'm going to add the equations to get 0. If I'm adding, I just put a 1 here and a 1 there. Okay, now now I've got -2, -1, and -11. Now what I'm going to do though is I'm going to show you what would the advantage have been to leave that one there and to make the first one -1. Why is that better? That's better because I ended up with positive coefficients, right? All along here. How did I know that would happen? Well, when I'm adding, I want the bigger number to be positive, right? Like the fact that this applet does all your numeracy for you is great, but you might be doing this by hand later, and you should get in the habit of trying to create positive coefficients whenever you can, because we know that we make fewer mistakes when we're adding and subtracting with positives rather than negatives. Sometimes you have to, but avoid it if you can. So what I had to do there is anticipate that, you know what, if I am going to be adding, I want to make sure I add to a positive, so therefore I want the larger number to be positive. And that's how I would know I would have to change row 1 and not row 2. Okay, so then I add the rows together. That eliminates z. Now what I've done is I need to make sure that z is eliminated in the third row. Well, you know what? It already was in the original equation, so I don't have to worry about it. So now in this case, there's something that you should do here. So look at this. If you notice, this says row 3 plus row 1. The new row 3 is row 3 plus row 1. Well, do I want to add row 1 to row 3 if I've already got a 0 there? No. So I want to have 0 of row 1. Okay, 0 of row 1. And that way, it just gives me row 3 is just row 3. Okay, so make sure that you're careful that sometimes you need a 0 there, right? Because you want to have just this row here because it already had 0. By adding them together or subtracting them, I would just be reintroducing a variable that I don't want to have there. So now what do? I've eliminated z from both row 2 and row 3. So here's what I do. I need to go down, and now I'm going to go to part C. Part C is solve a 2x2 system to determine 2 of the unknowns. By eliminating, so what we've done is we've eliminated z from row 2 and row 3. Now I can solve the 2x2 system for x and y. So what I need to do is copy down. So again, I select that, Control C is copy, and then make sure that you go to Paste Special, right-click your mouse, Paste Special, and Values Only. Then we go to row 3, right here. Control C, right-click your mouse, Paste Special, Values Only. And then I just double check. And notice it's color-coded for you. So your row 2 that you should be using is this one, right? And make sure, again, if you need to have, well, for row 2 there, and then row 3 you want to use this one, but make sure sometimes you need to have a 0 there, right? So now I have a 2x2 system where I'm going to solve for x and y. This looks like a pretty easy one to solve. So remember that this is x, this is y, and this is z. These are just coefficients, and this is the constant on the other side of the equal sign. So this means 2x plus 1y plus 0z equals 11. So this is just like you did in grade 10 academic, right? So what are you going to multiply? If you want to eliminate the x, what are you going to multiply the second equation by? Row 3, you're probably going to multiply by 2 or -2, right? So let's multiply by, yeah, -2. So let's try it. -2. Oh, whoops. Sorry, that's the common factor. I always forget that first set of calculations there is a common factor. You only do that if you're taking out a common factor, and there's no common factor. Sorry. So then we want to go down to here. We're going to multiply by -2 there. Okay, and I multiplied by -2 there, and now I can add. Okay, I can add. And here's the other thing. Yeah, that's perfectly fine. So let's add those together. So we've got the new row 3 is going to go to the new row 3 will be the old row 3 plus row 2, which we've got. So notice now it says I've got 15x or 15y equals 15. What do I need to divide both sides by? By 15. Okay, and I end up with, that's now y. So now y equals 1. Now I go into back substitution mode. Okay, in back substitution mode, what I'm doing is the next step, I know that y equals 1. And in this row, I've got x and y. So now I'm solving for x. Okay, I'm solving for x. And again, I know y equals 1. So how many x's are there in this row? There are 2 x's. So I change that to 2. Then I've got the 11 on the other side. That corresponds, that's why it's red and red. And now I need to subtract off 1y. Okay, so that has to become negative 1. And what's y worth? It's worth 1. Therefore, two x's, so if you take 11 plus negative 1 times 1, you get 10. 2 x's are worth 10. Divide both sides by 2. X is 5. So now we've got y, we've got x. What are we left to find? Z. Now we're going to go back to row 1. Remember, we went row 3, row 2. Now we go back to row 1 way up at the top. Okay, so we know at this point we figured out y was 1 right off the bat. Then we figured out x was 5. Now we need to get z. So I need to select z there. So I'm getting z. Now I go to row 1, red and red to help you track. So in row 1, I know I've got, how many z's do I have? 1x, 3 y's, negative 4 z's. So negative 4 z's is 12. Then I have to take away 1x. And that x happens to be worth 5. And then I have to add 4 z's. Because that's subtract 4. Remember, this is an equal sign right here. And that, oh, sorry. I have to add 1x, subtract 1x, and subtract 3y. I'm sorry, folks. Subtract 1x, subtract 3y. And that y happens to be worth 1. Okay, so altogether, negative 4z is worth 4 because 12 plus negative 1 times 5 plus negative 3 times 1 works out to 4. Negative 4z is 4. Divide both sides by negative 4, and z equals negative 1. And then you can always check your answers, right? Your answers are right here. 5 for x, 1 for y, negative 1 for z. Okay, we've got it. I'm not going to go through back substitution anymore. I think you'll have that idea how to do that. Now we're going to start working with a few more examples. Okay? All right, so let's look at this one. So when I scan these equations, negative 3, 5, 4, no common factor. 4, 1, 4, no common factor. 2, 7, negative 2, no common factor. So that's the first thing. The second thing is I'm looking for ones. I'm looking for ones. So, or negative ones. Row 2 has a negative 1. That's in the coefficients, that is. I don't worry about ones over here. I'm worried about ones in the coefficients. So I want to put that in the first row. 4, negative 1, 4, 1 is going to be row 1. I'd be looking for any zeros. If there was a single zero anywhere, that would go in row 3, but it doesn't appear that they have them. Okay, so I've populated this matrix already so that we can get through this a little bit quicker. Okay, common factors. We said there weren't any. Again, make sure that everything says 1 there for common factors, otherwise you're going to end up with decimals that you don't want to have. So what's the first part of this? I don't get to advance to part C because there wasn't a 2 by 2 within that 3 by 3. But now what I need to do is use row 1 and row 2 to eliminate a variable. Okay, row 1 and row 2. Remember, what's the easiest variable to eliminate here? Well, very clearly it's y, x, y, z. Anywhere where I have a 1, it's going to be easy to eliminate. So what do I need to multiply row 1 by? And you're usually going to be multiplying by row 1. If you've got a 1 in row 1, you're only multiplying by row 1. That's what's really great about this. So I'm going to multiply row 1 by positive 5. And now look at this. I'll be able to add the rows. Okay, I'll be able to add the rows. So 1 times row 1 plus 1 times row 2. That's equivalent to adding the rows. And now I've eliminated y. Next, I need to go down, and I now need to eliminate y in row 2. Or in row 3 rather, right? So first we use row 1 and row 2. Next we use row 1 and row 3 again. Or row 1 again with row 3. So again, this should be very straightforward because I've got negative 1 and 7. I'm eliminating y. So I multiply row 1 by 7. And again, I will add. Negative 7 plus 7 is 0. This is already set up for adding, so it does it nicely. So now what I do is I take, again, I'm going to match up my colors. So I want to copy that. And then paste special. Please do paste special. You can always do with the undo button, right? You know the undo button, I'm sure. So paste values only. And then same thing for this row, for row 3. Control C. And paste special, values only. And then I go through the whole process of solving a 2x2 system with x and z in this case. So do I have a common factor? 17, 24, 10? Nope. 30, 26, 34? Definitely 2. Okay, 2. So I've got a 2 there. I'm going to divide out 2. So this one here looks like it's not quite as easy. I don't have a 1 anywhere. So for this one, I'm going to have to multiply the first row by 15. And multiply the second row by 17, and now my x coefficient is equal, and I can eliminate that. So what do I have to do there? Well, let's think about that. Which one of those would you like to make negative? Right? So this is a case where I could have multiplied one of them by a negative, but I didn't. Since I am, and again, it'll work both ways. Since I wanted to have positives, I'm probably going to make, like the number of z's positive, I'm going to use row 3 as my negative. So that's going to be negative 1 of row 3 plus row 2. And I have 0x, 0y plus 139z is negative 139. So I need to divide that row by negative 139. And I will now have, oh, whoops, 139, my apologies. Not there. 139 there. Ay. So z is negative 1. Okay, z is negative 1. Let's go back up, just make sure we're right. Z is, in fact, negative 1. Okay, let's do number 4, or number 5, rather. So you know how to back substitute, right? So we're on to number 5. Let's quickly scan all of the rows here. Negative 3, 2, 5, no common factor. 4, negative 3, 4, no common factor. 2, 4, negative 3, no common factor. No ones, and no ones and no zeros. So this one here is going to require a little bit more work. So again, I've loaded everything in there. So I've taken the equations and I've created the matrix. By the way, the first 3 columns are called a coefficient matrix, and when you add in the constants, this is called an augmentation. To augment something means to add to it. So we call this an augmented matrice. Okay, there appears to be no common factors, so these are all going to be left as 1. Then we go down, and now we're going to start to eliminate. So first we use row 1 and row 2 to eliminate a variable. In this case, again, it doesn't matter. Usually we eliminate, in this case, we'll eliminate x, okay? Because there's nothing clear here to do, so you just do x. That's generally what's suggested. So what do I need to do? This is a negative 3, this is a 4, so I'm going to multiply this by 4 and this by 3, and now I've got equal numbers of x, except, well, equal but opposite. So what am I going to do here? I have to add the rows, 1 and 1. So now we've got we've got x eliminated from row 2. Now we need to use row 1 and row 3 together to eliminate x. How do we do this? Let's see, we're eliminating x. This is negative 3 and this is 2. So I'll multiply this by 2 and this by 3. And again, I have equal numbers, so I can add. It's set up to add right now, row 1 plus row 2, and it's adding. It's added that. So I've eliminated x from row 2 and row 3. If I don't have x in row 2 and row 3, what do I have? I have a system of two equations with two unknowns, x or with y and z, y and z. So let's copy them down. Control C, and paste special, right click, paste special, paste values only, and then remember that these are color coded. Oops, don't want to do that, but again, you can always undo any mistake. You just undo, and then again, right click and paste special, values only. You could also just key those in yourself too, right? So do a double check that they're right. They are. Okay, now I want to eliminate in this case y. So nicely, this is really nice, I've got a negative 1 there, so I can multiply the first row by 16. Oh, that's the common factor one. Sorry, folks. You can see I do that quite a bit. Probably should leave out, well, no, you still need to have the common factor part there. Okay, so now what we want to do is now multiply row 1 by 16. So I've done that. Now I can add, and again, it's set up to add. So for this one, 0x, 0y, 513z equals negative 513. If I divide by 513 now, that entire row, I end up with 1z equals negative 1. Let's double check and make sure z is negative 1 for this one as well. It is. And we would back substitute to get x and y. Okay, folks, hopefully that helped. You really need to do the practice on this because you can get very efficient at it once you get the strategy. And it's something that next year, for those of you that are, or whether you do this in stats in year 2 if you're a business or biology person, some business people do it next year, but you've got to get fast at it, because if you're not fast at it, it's going to take you forever to do the questions, and then you simply won't have success, right? You're just not going to have success because it's going to take you 3 times as long as everybody else, and you're not going to get all the questions answered. So you want to make sure you practice these. I think there are 9 practice questions on the homework tab, and you probably want to do all of those. Okay, folks, good luck.